Okay, Mr. Music, all good? Okay, g'day everyone. Welcome to my session on are you securing your rich client apps on the server? So just for the sake of formality, this course is Dev 213A and I am Troy Hunt. I look like this on the internet, look like this in person. I'm a developer security MVP. You'll find most of the stuff I'm going to talk about today either on my blog already at troyhunt.com or a bunch of this stuff I'm going to write up in a little while. Find me on Twitter, so please ping me on Twitter. I'm the one person who still has a Hotmail account as well, so you can find me at troyhunt at Hotmail. I've created a Safer Web project. Some of you who might have gone to Shane Morris's session on the UX Doctor the other day might have seen that, so it's just a free tool to look for security misconfiguration risks in your ASP.NET apps. And I'm also the creator of the ASP.NET OWASP Top 10 Security Risks, which you can find as a free ebook. And I'm a Pluralsight author, and that's all of the intro stuff, so now everybody knows who I am. Okay, so let's jump into it. Now, where I thought we might start, because we're going to look at a lot of devices, and we're particularly going to look at the security of the APIs behind the devices, and then some specific stuff about Web API. But I thought what would be interesting is to start by looking at some examples of some of the things we're finding in APIs. So just as a guess, how many people or how many apps do you think the average phone or device has installed on them, whether it's an iPhone or Android or Windows or whatever? Any guesses, number of apps? Average? 50, 80, 100? Wow, okay. So the figures I have seen, and these were from last year, were about 41 or something like that, and I thought that was high. But either way, it's a lot, and I think we just, you know, there's so many of them are free or they're cheap, and we just go yoink, 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 yoink. It's so easy to take. How many of those do you think have serious security risks in the way they talk to web servers and backends? Just I think if you try hard enough, it's probably going to be all of them. It's probably a fair significant number. Certainly the ones that I look at that do communicate with the back end, I'd say a good half of them have some pretty serious risks. And what we're going to look at today is how those risks can be identified very easily using tools that you're probably already pretty familiar with. So where I wanted to start is just a few examples of things I've seen recently. So I won't name names, but these are real examples. So I was looking at one recently, and this was an app in the public app store, and you'd download the app and you'd run the app on your iPhone, and you could proxy the HTTP traffic, and that's what we're going to look at today. And when that HTTP traffic got proxied, you could see that it was easy to find a WSDL, a web service definition language, and it's easy to find all the services that it exposed. And it exposed services like get all users. And it was really convenient because you could get all users and all the passwords were there as well. And you could find this. I'm sure somebody went, you know, it would be awesome, it would be really good if we could just get these things like that. Anyway, all the passwords, plain text. Made it very, very easy. And when I showed this to the guy, he said, oh yeah, but our users don't use Fiddler. Oh, okay. Well, you guys are all right then, don't worry about it. But you know, it's a very funny common reaction where they say, oh, well, we didn't think of that, no one else is going to think of that, don't worry about it. Another recent one, a bank, a Big Four bank, and I won't say which one it was, but a big bank who had a mobile app, and in fact I wanted to use this mobile app as an example of how to do it right. Because they had done a very good job, and I opened it up and realised that none of their traffic, it was encrypted, but it wasn't trusting the certificate. And this is something we're going to look at today, and effectively what it meant is that the entire SSL implementation was entirely invalid. So if they were on any network where a man could get in the middle, it's like having no SSL. This is a bank, you know, people transfer money. True story, it's fixed now as well. So look for recent updates in the App Store. But I'm not saying which one. So one more before we move on. It's an interesting one where there was an app that was intended for consumers who were visitors to a particular shopping centre in a particular place, and it had some very convenient features for the visitors. And in fact, they were so convenient that the visitors could take control of a lot of the shopping system control systems because when you traced it back and you looked at the server that the API was hitting in the web app, it had all these other very, very handy APIs. And it was another case where I spoke to the developers and said, you know, what gives? What's going on? Well, they said it was really easy because we could reuse it for all our internal administration systems, and then we could just reuse the same API for the consumers. So the interesting thing about that is that you don't even realise you're walking around with one of these in your pocket and it's consuming some of this information, other users' passwords, access to serious control systems. So anyway, that was just a little bit of a a taste to get you started. And interestingly, all of this stuff about leaking of data and leaking of information, I've done a piece with Four Corners. It's going to be on the ABC, 8:30 Monday night, a little bit of a plug. It talks about a lot of this sort of stuff and the amount of information that we're leaking inadvertently. Not just from apps, but from things like Bluetooth scanners and Wi-Fi scanners. So with that intro done, there are three main things that I wanted to talk to you about today. And the first one's going to be about hacking yourself first. And I'll explain that in just a moment on the next slide. I then want to take a really good look at transport layer security, because what's happening a lot of the time with our apps, particularly the mobile apps, is we're missing it all together or we're doing it really, really badly. And I'll show you examples of how to do it badly, and then I'm not going to tell you who, but I am going to show you how to go and find out who. And then you can do with that what you will. I didn't say that. Securing the auth as well. So we're going to look at authentication, we're going to look at authorization, and just cover off a few different concepts there. So in terms of hacking yourself first, the real sort of concept we're trying to get across here is that you've got to understand how to break your own applications if you are to secure them. It's very hard to just sort of live in this vacuum where someone says, well, you've got to protect against SQL injection and XSS and all this other kind of stuff, and you never get the opportunity to see how to actually break it and exploit it. So this is a Pluralsight course I just pushed this week, and while I think of it, I've got a whole heap of these Pluralsight things as well, if anyone wants to get free passes after the course, after the presentation. So the whole context is, how can we just observe things in the browser or on the PC or in the device that anyone can go away and look at straight after this and draw conclusions about the security profile? And that's what I really want to start off by taking a closer look at. Now, one of the things that we need to understand a little bit more about is who we're protecting our apps from. Because depending on the class of attacker, we're going to take a very, very different approach to the amount of effort, the amount of money, and the amount of inconvenience we put our users through in order to try and secure things. So three classes. The first class is hacktivists, so everyone knows about Anonymous and this sort of thing. And for the most part, these are kids. And I mean, they're literally kids. They're like 17 years old, a lot of them. And you see them going to court, etc. They're either 17 or early 20s or very, very young. They're always going to court with their mums, and their mums look seriously pissed. But they are literally kids, and they're using very often just free tools off the internet. I've got a video on my website where I teach my 3-year-old how to use SQL injection. Well, I taught my 3-year-old how to copy and paste, and then if you have Havage, you can do SQL injection. And that's the sort of thing these guys do. Because it's very easy just to do some Google Doc searches, find websites that have a parameter such as ID equals in them, copy that, paste into Havage, go, and it just destroys the database, brings everything back from the database. It's actually kind of cool. But that's how these guys are getting away with it. So mostly kids, they're opportunistic, they'll have a go at anything that's available. It doesn't have to be something that's going to be a great political cause. It doesn't have to be Visa card or MasterCard because they're not taking WikiLeaks donations anymore. If you're out there, you're a target. I think that's one of the important messages. As soon as we put something out there, whether it's an API or a website, it's public, it's accessible, people will start having shots at it. Good news is they don't have much money, they're not particularly smart. So all you've got to do is raise the bar just a little bit and you're okay. Now these guys are a little bit harder, cyber criminals. So cyber criminals have an ROI, okay? They want a return on their investment. If they can get a big enough return, they'll invest. They've got money, they run it like a business. They want to get things like user credentials. When they get user credentials, they can package them all up and they can sell 1,000 of them for $100 on the underground networks, of which there are many. So they do actually have a business plan. They're a lot smarter. And if your site has something of value to them, then it's a different ballgame to the hacktivists. The question is whether you've got something of value or whether you're just going to fall into that top category, which is a bit easier to protect against. Okay, these guys. These guys have got lots of money. And in light of recent events, we know that they're probably doing a lot of this as well. So nation states obviously have huge amounts of money. I was reading the news today, information about saying the NSA has pretty much broken all their encryption and they're looking at all their traffic and they've been doing it for ages, which probably wouldn't surprise many of us now after PRISM and those sort of things. But think about nation states in the sense of things like Stuxnet. So who's heard of Stuxnet before? About maybe 15% of the audience. So very briefly, Stuxnet made a lot of news a couple of years ago. It was a virus that targeted uranium enrichment facilities in Iran. And the idea was, you've got these centrifuges that do the uranium enrichment, and they're connected to computers, which is your first problem. But of course, you need these SCADA systems and sort of control system to manage it all. But they're all airlocked, right? So it's not like they're sitting on the internet and you can just browse over to them. So what appears to be a combination of the US government and Israel created these viruses that had things like 4 different Windows 0 days and managed to get them on USB sticks, managed to get them to the right people who inadvertently put them into the computers in Natanz in Iran, made the centrifuges spin too fast and bearings and things. I mean, it blows your mind, the amount of effort and cleverness that goes into it. And the real point is that if you've got something of interest to nation states, you're going to have to spend a whole lot of money to secure that. It's going to be very, very hard. And the reality of it is they'll probably get it anyway, if they want it enough. So the point is 3 very, very different risk profiles. And we do need to think for each of our apps, where do we fall into in terms of who's going to want to attack us. So I want to do a couple of demos, and my internet's not working. So it's going to be interesting, but I do have backups. And what I want to try and demo first of all is using Fiddler to observe, capture, and manipulate API requests. Who's used Fiddler before? Okay, and who has used Fiddler to proxy traffic from something else? All right, so maybe a quarter. Okay, so this will be kind of interesting. And out of interest, what are people using Fiddler for? Debugging analysis, right. It's awesome because every HTTP request from the machine goes through Fiddler. So it makes it very, very easy to sort of abstract a little bit from the browser and see what's actually going out through the wire. So what I'm going to do, and I'm going to show you how to do all this, and then I'm going to load my saved copy because I have no internet. What I'm going to do is set up my iPhone like so. Same deal with any device, we can set up a proxy. And basically we're looking at these bits here, the server and the port. So all I've done is I've gotten the IP address of my machine, which is not the one that you see there, so you don't try proxying things through me. You know who you are. And that's the default port, 8888. So you whack that in your device. Now what I'm going to do, in theory, is then load this app. Now the caveats first, there's nothing wrong with this app. In fact, it's an awesome app. It's Weather AU, only does Australian weather, as the name suggests. Very, very good app. And I thought weather is a pretty sort of mundane piece of data. No one really has to secure weather data. And in fact, they have done some things to secure it, which I thought was actually pretty cool. So what we're going to do is switch over to my other machine, and we'll see if we have internet or if we go to backups, and show you what it looks like. So first thing we'll do is start zoom it so you can see what I'm doing. Okay. So we'll grab Fiddler. Now the way you need to set Fiddler up, and I will zoom in when I get to the right bit, is when you go to Tools, Fiddler Options, there is a section here on Connections. Now the idea with your connections is as soon as you tick this box just here, so long as you've got your proxy set up to go through Fiddler, and it's using either port 8888, which you can see configured there, or an equivalent, then all your traffic starts to go through Fiddler. So let's see if I have any internet or if the whole thing fails. So the theory is, we say OK to all that. Oh, that's good. Cool. Go to my favourite weather app. Loading, loading, loading. So just imagine you see all these requests popping up there. Oh, there we go. It is working. Wow. Internet has come good. OK, so here's a good example. First request is just here. Now, what we're going to see here, it sort of breaks down into lots of different panels of information. Out of interest, Fiddler was created by a guy called Eric Lawrence, who was with Microsoft on the Internet Explorer team. He's now gone to Telerik, and Fiddler has come with him. So it's got sort of very, very clever backing. So what we're looking at here on the left-hand side of the screen is all the requests. And the ones we're really interested in are the ones where the host starts with Weather iOS. So they're the requests that my phone has just made. Now what happens is once it makes the request, we can then go over to our inspectors and we can then inspect that request. So what we're actually seeing here is we're seeing things like it was a post request, that's the path it posted to, and here's the host it posted to. So the first thing that should start to hit you here is it's not physically connected to anything, we're not routing phones, we're not doing any clever stuff here. All we've done is just change the proxy, and now we're capturing all that data and we can see it here. You've got no idea when you're holding this phone what host it's hitting or how many requests it's making or how big they are. You want to get a shock, open some apps and see how big the requests are. Even on 3G, megabytes and megabytes of images, literally this freaking big, so they can put a little thumbnail on. Off topic, but lots of dodgy stuff like that. That's on my blog as well, actually. I won't say which cable TV provider it was that does it. Okay. Moving on. So that is a quick look at the headers. Now within the headers, we saw it was a post request. We can also go and do things like look at web forms. Now what we're going to get in web forms is each of the parameters which was posted. Now in this case, we don't have any query strings, nothing up there, but we do have body values. So it's a post request, it's just, it's like form values. And we can see here, there's a bunch of values in the locations. Okay, so here's our values. There's a date stamp here, and I'm going to come back to why I think they're doing this, which is an interesting observation. And a whole bunch of other stuff we won't go into. The point is we can see everything that is being posted to the server. So that bit is good. Now we then have a response. And if we look at the bottom section of the screen, here is our response. So we can go and look at, say, the raw response. And when we look at this, we can see a whole bunch of stuff which almost looks random, but we can probably tell is JSON because it has lots of curly braces. And because it is probably JSON, we can probably hit the JSON tab. You wouldn't believe I prepared this in advance, would you? Okay, there we go. So we've got a nice little sort of JSON format. Now the neat thing about this from the perspective of sort of hacking yourself first, it makes it very easy to watch what's going backwards and forwards to your app, or anybody's app, as you're actually opening it in the iPhone. So that bit is neat. Now let's try, and I'm going to add a location, and I know it doesn't look very good with me just standing here, but just believe me. I'm going to go and search for Gold Coast. And we'll do a search, and with any luck, we will see another request come up. There we go, there's a search down there. Very good. And same as before, we can sort of see, if we have a look over here, there's the value of Gold Coast being searched for. That was in our request parameters. Inevitably, if we look at the JSON down the bottom, we can also see a response. So in fact, we've gotten the Gold Coast Seaway. I assume that's just the weather station that we're going to get. And all of that comes across very, very easily. So let's get into the little sort of hacking bit. And we're going to be very nice to them because they are a very nice company. I'm not going to do anything we probably shouldn't. But what we can do in Fiddler is, see up here, we've got this little Composer tab. Now what we can do with Composer is we can recreate requests and we can modify them if we want and then resubmit them. So all you do is you grab your request, you drag that guy over there, like that, and then you click execute, and it sends it again. And we should see it's obviously a very slow connection because all you buggers are on the internet and slowing it down for me, but we've got the same response size. So we've got another 23 bytes or 233 bytes worth of response. And you can just keep issuing requests over and over and over again. That's not very interesting though. It gets more interesting when you can do things like change the request. So let's make this say Sunshine Coast. That's good. Now let's execute it. And of course, you'd probably barely call it hacking to say, well, I'm going to search for the Sunshine Coast instead of the Gold Coast. But the interesting thing is, when we look at the response of this one, we go there, we go inspectors. This is quite different. So we've got some sort of error, status error. So why are we getting an error when we search for the Sunshine Coast? Now, I honestly don't know the answer to that, but I do have a theory, which is that when we look at the request parameters, and I'll zoom those in a little bit like that, we do appear to have what might be HMAC, so a hash-based machine access code, or in other words, a way of saying on the device, let's take a string, which would probably be all the request parameters, let's put them together, let's get a key, put that together, hash it all, send it through there, and then repeat the process on the server. So what's happening here is the server has got a way of validating the authenticity of the request. Now, what I think is happening is the server's making sure that somebody isn't manipulating the request. So even though it's just request to weather, I mean, it's not people's accounts or things like that, they've actually tried to stop people from being able to go in there and just hammer their service. So I wasn't originally intending to show that, but it just came as a result of mucking around with their API, and I thought it was interesting as an example of how you can still get some authenticity around your request without things like HTTPS and so on, which we'll look at in a moment. Of course, there's nothing in here that we'd really want to protect over transport layer security anyway. We don't particularly need to protect the temperature on the Gold Coast. Okay, so that's a quick example of composing and reissuing a request. Now, of course, what you want to do with your own apps is start to do much nastier things. So what happens when I try and make a request to somebody else's account? Pass a different account ID through. What happens if I try and brute force an API? And I'm encouraging you to try and get into Fiddler and start doing this sort of stuff because you find all sorts of amazing things with your own apps, not other people's apps. Okay, one more thing. Now, the last thing I want to show you in Fiddler before we jump back to some slides is to look at Fiddler script. Anyone used Fiddler script before? Oh, cool, this will be new. All right. So Fiddler script is very, very small. Fiddler script, what Fiddler script can do is it can hook into a number of events in the request and response. So you see here we've got things like on before request, on before response. So for example, on before request, when we made a request to that weather app, because Fiddler is sitting as a proxy in the middle, and what we've got to remember is that Fiddler could also be any point along an insecure network, and we'll talk about that in transport layer security in a moment. But what Fiddler can do is manipulate that request. So in some of the demos I've got on my website where we look at things like the risk of loading login forms that might be HTTPS, but you load them into an insecure page, we can manipulate requests. So we can say, rather than go and get HTTP whatever image, go to somewhere else and get the image. The device makes the request as normal, it just gets a response from somewhere totally different. Now on the flip side, we can modify the response. So what we're looking at here is what happens once the server responds, but it hasn't quite yet gotten to the device. Let's see what happens if we can modify that. So we will just jump down to on before response, and I have some pre-existing code. I'm going to comment and then explain. And we'll just take that guy out there. Okay, so this is pretty straightforward. It's Fiddler script syntactically. It looks very similar to JavaScript. And all we're really doing here is saying, if the host name is this one we've been hitting, whether iOS, etc., and the path in the query is this guy just here, which is the big summary when you first load your phone, we're going to decode the response, we're going to get a string from it, and then we're going to do a nice little replace, because it's not fine and partly cloudy here, it is developers, developers, developers. So, let's have a look at what that actually looks like. So now what we need to do is we need to save the script. It doesn't work if you don't save it. You will find that out very, very quickly. And what I'm now going to do is open up my phone here, and I go there, cancel that guy, back to there, close, reload, and we'll probably see another request pop up there. So there we go, we can see that one down the bottom. Thinking, 120K worth of response. It's not much point showing you this one, so here's one I prepared earlier. It now looks like, hey, magic. Now, why is this important in a security talk? It's important because it demonstrates that you might create the API and you might create the app, but one can't really trust the other. Because at the end of the day, the app is going to be put in somebody's pocket. They can sit in the middle of that communication, and I'm probably thinking about HTTPS, we're going to look at that. They can manipulate the response. So an example of where that could be leveraged for an attacker's advantage. Let's say you create a game, and there's a lot of API communication, which obviously happens in a lot of games. Don't depend on the API to allow the app to take the person to the next level. Because if someone can get in the middle of it and say, well, I'm going to get the API to tell my phone something completely different to what the API should be telling my phone, then you've got a problem. Now, that one's probably not too serious. I've seen things like shopping carts that are very dependent on the server to tell the cart what the value of the cart is, and then sends the value of the cart back as part of the transaction and doesn't necessarily recalculate it all again. So the point is, you've got to expect that someone can sit there in the middle and effectively man in the middle, and we'll look at that in a second too, man in the middle their own device in order to change the behaviour of the app. So all of that again is still really hacking yourself first. So what happens when you muck around with your own phone, your own APIs? Can you get it to do things that it's not meant to do? If anyone has any questions as I go through as well, please just yell out because it's much more entertaining. Okay. Who's on the free Wi-Fi? Come on, everyone. I've got 4 devices on the free Wi-Fi. Everybody is on the free Wi-Fi. Everybody loves free Wi-Fi. Who trusts it? Nobody. Oh, man. That wasn't me. Seriously? Yeah. Well, you mean from the Wi-Fi? So did someone man in the middle of you? Or? Crikey. Okay. I have heard stories about TechEd Wi-Fi before. I don't know if they're true. I've heard a lot of stories about things on TechEd before. I don't know if that's true, but the interesting thing is, of course, the TechEd Wi-Fi is open, right? I mean, there's no password. So none of us have any encryption whatsoever between the devices and the access points. And to be quite frank, I don't know why they do that. Even if they had walked around and stuck great big passwords over every wall so everybody could see it and everybody could use the same thing, we'd have a more secure position than what we do now. Because the big problem is it's very easy to look at traffic that is flying around the network that's not necessarily destined for your device. So if you have a promiscuous network adapter, or sometimes called a network adapter that can go into monitor mode, a lot of cards will do that already, otherwise you can get a real cheapie off eBay and plug it in. You can see all sorts of traffic that's flying around. Who uses Stack Overflow? Everybody uses Stack Overflow, come on. So Stack Overflow logs you in using an OpenID provider which implements HTTPS and all the right security bits, gives you a token, and then every request you make to Stack Overflow is in the clear. It's over HTTP. Now I know that probably in my browser at the moment I've got Stack Overflow open. It's sending that authentication token over the clear. It would be so easy to find so many authentication tokens for Stack Overflow flying around here at the moment, and you could all go and vote up the SharePoint questions or do something like that, just by grabbing someone's token, putting it in your own browser, so basically just creating a new cookie with somebody else's token, and you have a serious problem. It's something that they're working on. There's all sorts of issues, but that's just an indication of the risk. So let's move on though, because I don't want to start going through some actual slides. So the first thing to think about, because this is going to lead into talking about a man-in-the-middle attack, is that an HTTP request has a pretty long way to travel. And I think we all sort of intrinsically know this, but just to go through it again, so you have a device, which is of course a Surface Pro. Your device then talks to, in this case, a wireless router, which of course here it's doing so insecurely. Okay, imagine you're at home and it's an iPhone or whatever, and you've got WPA and all that sort of thing. You're going to the wireless router, it then goes out over whatever telephone networks or cable networks your ISP is giving you, finally hits your ISP then goes out all the way around the World Wide Web, and eventually ends up on the NSA's, eventually ends up on somebody else's, server. And then, of course, the whole thing happens in reverse, right? So we go backwards. It goes back from, all right, it is the NSA server. It goes back over the World Wide Web, back to your ISP, back over the telephone networks, back into your router, and then back into your device. So particularly for us here, and just about everything's in the US, I mean, we're going through a lot of different nodes. Our packets are travelling a long way. Now, what we've got to remember is that this concept of a man-in-the-middle attack is something that could happen at any one of those points. And we very frequently just think about man-in-the-middle as being something that happens on Wi-Fi networks. And it's not the case. Well, it certainly does happen a lot there, but it happens in other places. So let's start by understanding a man-in-the-middle attack. So, who's excited about the election? Yay! All right, let's imagine, because I wanted something topical, we'll go back a few months, and think back around June. And Jules says to Kev, she says, "Do I have your support?" And we all know that she was saying this. And we all know what he was thinking, right? We all know what he was saying. But how many people saw Jules stand up and say, "No, I've got everyone's support, it's all good"? So there must have been a man in the middle, okay? Now, the way a man in the middle attack happens is one party in the message sends a message like this, and he changes it. So this is what happened. Anyway. Now this is an example, in all seriousness, this is an example of an integrity problem with a message. So the message is actually being manipulated into something else. Now, of course, the man in the middle could also result in a confidentiality problem. So here, all on this wireless network, I spoke about promiscuous adapters, etc. You could be sitting there watching other people's traffic and being a man, almost a man on the side, observing the traffic, but not necessarily changing it. But they're two different important concepts. We're going to look at them more in a moment. So integrity and confidentiality. Now, what often happens is we talk about man-in-the-middle attacks, and everyone goes, "Oh yeah, but it's not going to happen. You don't need SSL. It never really happens." And of course, every time you see a login form that doesn't have SSL, everybody's like, "Oh, that's terrible." So there must be something to it. And what I wanted to do is look at a few different ways where there could be a man-in-the-middle attack mounted. And I didn't want to just focus on Wi-Fi. I wanted to give it a bit of a broader breadth. So you could do something high-tech and spend about $2 at the hardware store and get a couple of clamps. This is a passive Ethernet splice, as the title suggests, and this is saying, hey, we've got a cable, we're just going to yoink, jump onto it and monitor traffic. I mean, it is obviously very, very rudimentary, but I think it's also kind of elegant in its simplicity. Now, this could be happening on the cable plugged into your computer at work, and of course you could look at the cable and see it. It could be happening behind the plug of the computer plugged into work. Now, the point with all of this stuff I'm going to show you around man-in-the-middle attacks is that all of this stuff can happen, and we've got to expect that the transport layer can be compromised. And that then brings us back to, okay, well, if we expect it's going to be compromised, how are we going to protect against a compromised network, which will draw us nicely into HTTPS. Who knows what this one is? Pineapple? Yeah, some people read my blog. All right, so this is obviously a pineapple. So let me explain what this does. I wasn't allowed to bring this, so I can't show you. Let me explain what it does. It's about the size of a cigarette packet. It obviously has an aerial, it's got a wireless access point, it's got a couple of RJ45 Ethernet adapters, and it's got a USB plug. And it can run powered off mains or from a little battery pack. And it can do a few different things. So one of the things it can do is it can be what we'd call a rogue wireless access spot. Now, how many times do you go to a cafe and you sit down, you want to have a coffee, you pull your phone out and you go, oh, free Wi-Fi, yeah, jump on here. So you can set this guy up to have an SSID that says free Wi-Fi. You can then, through the Ethernet cable, route that traffic through your machine and then go out through your machine's connection and capture every single packet that anyone who connects to it sends out over the internet. So that's a really good example of a man-in-the-middle attack. And, you know, I mean, it's easy. You go to a public spot and I'm told that many people will connect to something like this. So that would be one way of doing it, but that's a very conscious activity. Someone has to say, yes, I want free Wi-Fi, and either unknowingly or maybe just a bit recklessly connect to it. The other thing this can do, and this is the real cool party trick that I'm really sad I can't show you, everybody's phones and devices, and like I said, I've got 4 different things connected to the Wi-Fi at the moment, which after this I might disconnect. All of these devices, when you connect to a network, so say you connect to your home network, right, and you say, you know, remember my home network so that when you go to work and you come back, it automatically connects and everything is so easy and seamless. Now, what actually happens is as you're wandering around, your device is sending out what they call probe requests. And these are little requests that go out with the device's MAC address and the name of the SSID that it's looking for. So everybody's devices are doing this, all invisible, trust me, it's in the air. Everybody's devices are sending out these little probe requests, and there would be hundreds and hundreds of them going out right now. Now what the Pineapple can do, it's got a feature called Karma, and what Karma does is it looks at the probe request, and it sees a probe request for, say, Richard's home network. You're closest, sorry. Now, it sees this probe request, it changes its SSID, and suddenly the SSID is Richard's home network. Now, if Richard's home network is not secure, and I'm certain it is, but if it didn't have WEP or WPA or WPA2 or any sort of, if it was this network here, what would happen is Richard wouldn't even take the phone out of his pocket, but he'd automatically associate to the Pineapple. So he's not actually touched the device, and now there's this association so that the thing's still in his pocket and all his traffic is now going through the Pineapple because he's found his remembered favourite hotspot. So that's a really nasty thing, and the problem with it is, and in all seriousness, in a case like this where we have all connected to the Microsoft Event Network, when you walk out the door, your phone is saying, give me Microsoft Event, give me Microsoft Event, give me Microsoft Event. You'd only have to sit over at Jupiter somewhere and you'd see all these requests for Microsoft Event. Something like the Pineapple could then change its SSID to be Microsoft Event, and you guys would just associate, and because there is no network security whatsoever, it's not expecting to do a handshake, so the association just happens. So that's very cool, and there's a couple of things on my blog about how that works, including from another presentation where I did use it, and I just had hundreds and hundreds and hundreds of probe requests with people's SSIDs that we put up there. So if you come to Web Directions in Sydney next month, I'll do that. Okay, so that's Pineapple. Now the other one, so this is, well then all their traffic goes through the device, so you can either just capture all the packets, so you can save them onto the, you can whack a 64 gig USB stick in there and just capture traffic until it fills up. You could mount a man-in-the-middle attack where you change the traffic. You could run something like SSL strip to get, and in fact we'll show you an equivalent of that later, but basically get in the middle of an initial HTTP request or something like a bank and then proxy traffic backwards. I mean, you could do anything because you control the traffic. Yeah, so you could just sit there and wait and see what happens. So, and then you sort of get into the realm of, okay, how's it going to be used? Is it targeted? Are they looking to get someone sort of specific online here to grab a hold of credentials or some specific thing of value to the attacker? Or is it just a very random attack where I'm going to sit in a cafe and just see how much crap I can catch? Or somewhere like this. It'd be the sort of thing where it's like, I know I'm going to get a heap of, say, Stack Overflow credentials, or probably not credentials because, again, they do a good job of that, but Stack Overflow auth tokens so that I could then jump on and impersonate people. Okay, so I thought this one's a good example because this sort of starts to move the concept of transport layer security away from things in your direct control. So this is no longer about your device or about your cable or about your router or anything like that. Now, this is from a couple of years ago when things were a little bit unstable in Tunisia. And in Tunisia, apparently the governments own all the ISPs. And I'm sure in many countries of a similar sort of political nature, the governments have a lot of control over what happens at the ISPs, which means that they can start to man in the middle people. So what they were doing is saying, when you load Facebook, and Facebook loaded the login page over HTTP, it posted to HTTPS, and lots of people said, well, it's fine, because when I put my credentials in, it posts to HTTPS. And they're right about that little bit. The problem is that when you load that Facebook login page, if you can control the transport layer, you can do things like inject keyloggers. And this is not a keylogger that installs on your machine and it's malware or that sort of thing. It's just JavaScript. On change event. How easy? On change event, send credentials or whatever's in the text boxes off to the government. So that's what was happening. So the actual login page had been compromised before anybody put any credentials in there whatsoever. It's a really good example of how no matter how well you control your immediate environment, there is something upstream which could be compromised. So it sort of comes back to why we need to have some sort of intrinsic security all the way from the device and to the server. Okay, so at the moment, when we open our browser and we see this, would we say that this page is secure in terms of the transport layer? Looks good. It's got a gold padlock, must be good. For those who don't know, I'm not real fond of... You see some websites put little bitmaps of a padlock. They have no HTTPS, but look, I've got a bitmap of a padlock on my page. It must be awesome. It's terrible, don't do that. It's the same with some of the certifications, like from Norton or McAfee. They put these great big certifications on there. We're secure, we've never been hacked, and it's on a freaking HTTP page. What's the point? Anyway, so in a case like this, the address bar's gone green, which means it's an extended validation certificate. So the website has had to jump through all sorts of hoops to prove who they are. And we can see that in the address bar up there, it also says it's St. George. And then we've got a big green tick, which goes nicely with the padlock. And then if we're really paranoid, we can go and inspect the certificate. And we can see it was issued to ibanking.stgeorge.com.au, issued by VeriSign, and it is valid until a few weeks from now. So all of this is fine, and the point is that in the browser, it's very easy to establish the security position of how data is going backwards and forwards over the transport layer. I'm sure everyone's done this. You look for the padlock before you put in your credentials or your credit cards or things like that, and if you don't see it, you get a little bit wary. Is this secure? No idea. I have no idea. And the problem is that as a consumer, you've got no idea, right? I mean, okay, we now know that we can put it through Fiddler, and we'll have a look at that in a moment, and we can tell what's going on. But as a consumer, and even for us as technology folks, you know, you pull your device out and you look at an app, you have absolutely no idea how it's communicating over the transport layer. As a tester, you have no idea how it's working unless you're going to drop down into that HTTP stack. And the thing that sort of strikes me with this is that it starts to become a sort of a degree removed, right? So no longer are you seeing the address bar with the HTTPS and the gold padlock and the green bar and the green tick. You know, all of that starts to disappear. And what I'm seeing is a huge amount of apps that are not actually doing any transport layer security, or they're doing it really badly, and nobody knows unless they actually go in and take a look. So this sort of brings me through to Web API. And look, I mean, a lot of this is relevant to any sort of API that works over the HTTP stack. But we want to put a bit of a Web API spin on it as well, because it's very easy to prevent this sort of stuff with Web API. And the first thing we've got to remember with Web API, and out of interest, who's built Web API before? How many people? Oh, wow, okay, about half the room. Awesome. So, I mean, it's dead simple, right? It's really, really simple. And the whole thing is that it is ultimately just HTTP. And the way we protect HTTP for an API, whether it's Web API or any other sort of technology stack, is the same way that we would prevent or rather protect any sort of HTTP communication in the browser. So we're really just talking how are we going to protect things like the classic HTTP verbs, get, post, delete, put, and any of the other more obscure ones that you might use. Now before we go into that, 3 things to understand about SSL, and we've kind of touched on these already. We've got to get away from thinking that it's just about encryption, because people think it's just about encryption, we're okay. The Facebook example with Tunisia, the credentials were encrypted when they were sent to Facebook. I mean, before that they had a really big problem because the credentials were being sent off to the government. But they weren't thinking about that first point about integrity. It was really, really important to have integrity of the login form, but they didn't have it. Now, confidentiality is pretty obvious. Passwords, bank account details, anything that we don't want public, including things like authentication tokens. So if you're building web apps, particularly if you're building ASP.NET and you've got an ASPX auth cookie, you've got to look after that guy, because if he gets grabbed by someone and they put it in their browser, then they become you, and that's sort of the problem of Stack Overflow at the moment. But the third point there as well, around authenticity, there's no point having a secure connection to an attacker. You want to know who you're talking to, and this is one of the premises of this certificate-based mechanism that is HTTPS or SSL or TLS, and all of those 3 terms tend to get used a little bit interchangeably, but ultimately we're talking about protection of the HTTP protocol. So we're going to look at authenticity in a moment as well. So what I want to do now is just look very briefly at a web API I have that doesn't have this level of protection and how it is quite easy to add. And one thing as well, before I forget about it, with SSL, so a lot of people have been worried about using SSL, and I know we should call it TLS now, but lots of people call it SSL. A lot of people have been worried about things like expense. So who knows how much it costs for an SSL certificate now? You're paying too much money. Zero. Start SSL. You can go to Start SSL and you can get a certificate for free. And it is a certificate authority that is trusted by all the major devices and things. So you can literally go there and get it for free. To be honest, the user experience isn't particularly nice on their website, but it is a free SSL certificate. And for the people that think if you put SSL on, then things are going to run like crap because the server is going to be too slow because of all the encryption, when Google went HTTPS only on Gmail, they said it had an impact of about 1% of CPU overhead. It can still cache if it needs to. All the other sort of dramas that people used to be very worried about with SSL, including load times. I mean, there's like a fractional sort of number of milliseconds of overhead. They're not really a problem now. So there are not many excuses left not to use SSL. The best excuse actually is AdSense doesn't support it. So when websites want to use AdSense and they want to go HTTPS everywhere, they can't, because if they put an unprotected resource in there, then the browser gets really unhappy and throws its hands up. So anyway, HTTPS is becoming ubiquitous and easy to get. So has anyone used this before in MVC? All right, so this is awesome. It's so easy. It's one line. If you have this, everything will be secure. No, it won't all be secure. But if you have this in an MVC application, this neat little authorization filter, it will ensure if you put this on either a controller action or on the controller itself, or you can register it globally, every request has to be HTTPS because it's required. And it's really that simple. Now, of course, you still have to have the infrastructure behind that. You have to have the certificate installed and the host headers bind and all that sort of stuff. So you need to have the bits working. But if you have it in place, putting on that require HTTPS authorization filter ensures that you can only ever make an HTTPS request. So let me jump over to the other screen. I'm going to give you an example of what we're going to do here. So I have a website here, and this is a website from the Pluralsight course I pushed this week. Free passes. Only valid for one. No. They'll work on any course. There's like 700 of them. Let's move on. So I'm logged onto this website at the moment, and I've got a little feature in here where, let's go and say view the P1. I like the P1. Now the idea is this website is sort of the one website that stays with you through the course and you delve down and find more and more and more really shoddy vulnerabilities. Now one of the things it does is it's got a nice little, it's all very bootstrappy and jQuery and API and all the things that we're meant to do now. So it's got this little vote feature, and what you can do is you can go in and leave a vote somewhere. Nice. Now what we'll do before we submit this is we'll just hit the developer tools. Oh man, this is IE 11. All right, this will be interesting. You know, I was going to use this, and it was going to be so cool because I was at TechEd and I was using my Surface, and then it didn't work. So it wouldn't go out to the projector. All right, so who knows where the network profiling tab is? It must be here somewhere. Network. There we go. All right. So we're both going to learn something here. When we vote. Okay, I did just learn something. Thank you, everybody. Let's go find another car. Let's take the Ferrari. All right, let's vote. I guess we just play. Network traffic capture. Okay, this is also nice. All right, let's try this. All right, so there's one request. I'll zoom in on this in a sec. Now, you know what? You used to be able to double click on that. There we go. All right. So here's what we can see. Post request posted to an HTTP address. It is in the API controller, and it's going to be the vote action, assuming I've got all the default routes set up. So that is fine. And if we then go through and take a look, we normally have a response in here somewhere. Response headers. It's actually come back with the 201 created, which seems okay for creating a new record. Beautiful. Now, let's jump over and have a look at the controller. Now, here's the thing. We just looked at the require HTTPS authorization filter, and that sits in system.web.mvc, and Web API sits in system.web.http, so we don't have access to that authorization filter. And everybody, please don't write SQL statements like this. This is meant to be a very bad application for obvious purposes. But we are going to fix one thing, which is this particular API. So anyway, the point I was making is that require HTTPS is not a native part of Web API. We need to implement it ourselves, but it is also dead easy. And I have implemented it already, so I can call into it. Let's go require HTTPS. And in fact, I have a little authorization filter over here, and I just want to show sort of how easy this is, if it will let me zoom in. Okay, so authorization filter. All we're doing is jumping on board the on-authorization event. We are looking for if the requested URI, has a scheme that is HTTPS. Now, if it is not HTTPS, we're going to create a new HTTP response message. And by the way, I stole this off the Web API website. So if you want to see this, don't bother taking notes. Just go to the Web API website on, I think it's asp.net/webapi or something like that. It's the official one. It's got lots of good examples like this on there. But this is a very neat way to do it. Now, basically, it's going to create us a new HTTP response message. We're going to get an HTTP status code that is forbidden, and we're going to get a nice little phrase in here saying HTTPS required. Now, in reality, this is still going to allow the request to be made. If there's sensitive stuff in there, it's still going to be posted via HTTP. But when you're building this thing and debugging it, you're going to figure out really, really quickly that you've done something wrong. So it wouldn't save people if it was actually a live system. They'd still be sending stuff over an insecure connection, but you will hopefully find out well in advance of that. So we'll go back there, we'll rebuild it. I'm running this on a local instance of IIS because it's a little bit more reflective of what a website would be like in real life. Let's now go and find another car we can vote on. So that thing is just going to reload itself for the first time. So what we really want to see when we vote this time, because obviously the scheme we're seeing here is HTTP, is we want to see that get rejected by Web API. Let's go, I like the Aston. I'll pick the Aston. Okay, Aston. Okay, let's vote for this guy. Be creative too. Okay, vote. Now, ooh, okay, so that doesn't look good. Let's have a look at what has then happened in our request, which is down here. And we'll double click that guy, and in theory it will open. We can maybe go to details on it. No, we'll just go to details. Okay, so what are we saying here? It is still posted to HTTP. It's basically just exactly the same request, but the interesting bit is going to be in the response. In fact, what we can see here is there's the 403, and here is that little reason phrase, HTTPS required. So this has actually rejected a non-secure request, which is exactly what we want. So let's do something very tricky and change that to an S. Now, inevitably, what we would do with a site like this, we'd probably just want to either load the whole thing over HTTPS because we are passing around authentication cookies, or we'd want to make sure we're explicitly calling into HTTPS on the API. Now, I'm conscious I'm meant to be talking about smart devices consuming APIs, but from an API perspective, it's the same deal. You can call this API from a client, and in this case, we really want it to be HTTPS. 3. There's a 3. Okay, done. Wow, demo worked. Awesome. So that has now worked because it was an HTTPS request, and just to make sure that we weren't making that up, if we go down to that last request, we should see that it was request headers. Okay, there it is. HTTPS. Beauty. So that worked, and that was a pretty sort of simple demo. So require HTTPS. It's nice because you can use it the same way as you'd use it in your MVC, but you do have to implement an authorization filter specifically for Web API. And don't forget, you actually need a certificate to make it all work as well. All right, so let me jump back. Any questions, actually, as I'm going along while I have a water? Everybody's happy? Very good. Okay, so the next demo. And I flicked to this screen so I could show you one slide. This demo is going to be around securely sending traffic to an attacker over SSL. Now, this is the point I was making around authenticity. So it's not enough just to have HTTPS and SSL and all these sort of things. We've got to make sure we go through some basic processes, which in many cases is about not disabling fundamental processes that are there to save you behind. So what I want to show you here is what happens when we make an insecure request. And in fact, I'm going to show you how Fiddler can track this. So what we'll do is we'll jump back over to Fiddler. Now, one of the things you can do in Fiddler is you can jump up into Tools, Fiddler Options, HTTPS. Now, when you do that, you get a nice little decrypt HTTPS traffic. Now, this isn't some secret NSA trick to decrypt things. What's going to happen here, when we tick that box, is Fiddler is just simply going to say, when the request is made from the client, actually I'll show you that too in a sec, when the request is made from the client, relay the request to the server, get the response, open it up, because basically Fiddler is the client now as far as the server is concerned, read it, change it, do whatever the hell we want with it, wrap it back up again, and then encrypt it with its own certificate. So when the client gets it, the client is actually getting Fiddler's certificate. And what you're seeing here is Fiddler is saying, well, first of all, it's scary. Please take note of that. So scary text, do you want to trust the Fiddler root certificate? Now, if our client trusts the Fiddler root certificate, it's going to trust the response. Even though we're going to make a request to a website that really shouldn't give us a response with a Fiddler certificate, the client is going to trust that Fiddler certificate and go, it's all okay. This all comes back to the fact that we've got certificate authorities. Certificate authorities, there's a handful of certificate authorities. They're the ones who issue certificates. All your devices trust those certificate authorities, and they validate certificates against those. So it's probably another good talk for another day. But for the moment, we're going to assume that everything is fine with certificate authorities. We're going to decrypt traffic. We're going to delete everything that is in there. Now, in theory, if we have internet, because I didn't think we had internet. Let's see. We'll just go to Bing. Bing doesn't work. Bugger. Let's see if something else can go to Bing. We might just grab you incognito. Now the magic's. You ever notice sometimes Google defaults to HTTP, sometimes it defaults to HTTPS. I don't know why. There we go. Now, what's happening here, I'll zoom in on that guy, is that we've made a request to Google. Fiddler's gotten in the middle. It's gotten the response. It's put its own certificate in there and said, here you go, I'm Google. And the browser's gone, no, you're not. No way. And in fact, if we do what you should really never do, and you know what, Chrome doesn't let us do it because Chrome's very clever when you try and load Google. It gives you all these extra protections. But let me go to my own website. And Chrome is not as generous to me. Actually, no, it's not letting us do that. Maybe they changed it. Anyway, what you can normally do is you can say, to hell with it, I'm going to live life on the edge, I'm going to proceed anyway, I'm going to accept this invalid certificate regardless of all the red warnings. You get through, you've still got that massive, great big cross up here, like so. Red security warnings on web pages, normally bad thing, so don't do any apps that cause those. And basically what happens is you're getting that Fiddler certificate. Now, the point of all this is to say that the browser is validating the certificate. So the browser is making sure that the person you're talking to over HTTPS is the person that you're meant to be talking to over HTTPS. The problem that we have is a lot of mobile apps aren't doing that. So I have a mobile app here on my mobile. Let me see what happens if I do this. So, there. Ah, I'm on 3G. All right. I've been booted off the network. What happens with a mobile app that doesn't trust the certificate or doesn't validate the certificate, it just implicitly trusts it, is the connection still goes through, it loads the data over HTTPS, and basically you don't know. So what we really want to be seeing, if we go back to there, this is what we want to see. You might be connecting to a server that is pretending to be ibanking.stgeorge.com.au. So this is a St George app. Now before we said, can we trust this app? We don't know. Well, now we've just validated that yes, it is communicating over HTTPS, number one, so that's good. Number two, it's validating the certificate. When it gets the certificate back, it's making sure it gets the right certificate for St George. Lots of apps, including that bank that I mentioned earlier on, are not doing this. So you can put Fiddler in there and it can get all the traffic and it can change it and you can do whatever you want. So the question is, why are developers doing this? Why are we turning off certificate validation? Because it gets in the way the whole time. Certificate validation gets in the way. You want to create a self-signed certificate on your machine and test, and you don't want those nasty bloody warnings and things getting in the way. You just want it to work. So they turn it off. They turn it off in Java. They turn it off in Ruby. They turn it off in Xcode. They turn it off everywhere, and if you go through the web, you'll see all these things. I'm getting these nasty security warnings. How do I make it stop? Not how do I make the problem stop, how do I make the warning go away? This happens a lot. Now, it's because we are working with self-signed certificates in many cases, and it's perfectly valid to work with self-signed certificates for the purposes of development. We want to make sure, though, that we're never disabling that certificate validation. Because sooner or later, you'll put it into production. This is what happened to these banks, and believe me, banks put a huge amount of effort into security, but one little stuff up like that, and your HTTPS is just totally out the window. So never disable the validation. You want to trust the certificate. So you can create a self-signed certificate, and you can trust it on your device. In fact, that's how the demo that didn't work because I'm on 3G worked. I basically trusted the Fiddler root certificate on my device, which means that I can sit Fiddler in the middle and I can proxy traffic backwards and forwards, and I can see what's inside it, and my device won't throw any errors. Now, incidentally, you can do that with any app as well. So if you fire up Fiddler, and you fire up that little HTTPS bit, and you say decrypt HTTPS traffic, and you trust the certificate on your device, and there's a web page somewhere on Fiddler that explains how to do that, you can go to banking apps or any other apps on your device that are communicating over HTTPS, so long as they're not doing something like certificate pinning, where they say this is the exact individual certificate I want to see, and it's a bit rare to see that, you can actually look at the HTTPS traffic that your apps are sending backwards and forwards. Now, you're doing that because you've compromised your device. So it's not that you've magically broken HTTPS, but it's a reminder that you can see everything that is going backwards and forwards from apps on your own device, even when they're using HTTPS. Damien?
Is the Fiddler certificate the same on your machine as well as everybody else's machine?
No, in fact, someone asked Eric that the other day because they're thinking they'd found some magical error in Fiddler. It's generated, and it's generated per user as well. So if you have multiple users on the same PC, they generate their own Fiddler certificates, but it's a good question. Okay. Does Fiddler validate upstream certificates? That is a good question. I think it would defer to the local certificate store on the machine. That would be my best guess. If you're not sure, Eric Law on Twitter is the man who will give you absolutely every answer to Fiddler, and he's very good at answering things on Twitter as well. Okay, I think I'm starting to get close to time. So let's talk a little bit about auth, and we use this term a little bit interchangeably between authentication and authorization. And we do need to distinguish a little bit between them, because they're very fundamentally different concepts. So we're going to use The Simpsons, because it's universal. And let's take a scenario. So you go into Moe's and you want a beer. Now, inevitably, if you go in and you want a beer and you look young enough, Moe will come back with the 401. And effectively, what he's saying with the 401 is unauthorized. It's a challenge. You have got to prove your identity to me before I'm going to give you a beer. And in fact, he's interested in a specific claim. So he's interested in the fact that you're 18 or older, as we have it down here. So now we get into this thing of, okay, well, how are we going to verify identities? So let's imagine when you walk into a bar, what you'd normally do is you'd present your driver's license. You have your driver's license, that's your identity. We go back a step. What do you have to do to get your driver's license? I looked it up, it's painful. You need one Category A document and two Category B documents, or two Category A documents and one Category B document. A Category A document can be a birth certificate, a certificate of citizenship, or a passport, and then Category B can be Medicare, or it can be a credit card, or it can be not a driver's license, we're trying to get a damn driver's license, a student card. Now, if you go into the RTA and you give them all this, this is effectively authentication. This is giving them credentials, giving them enough information that they can have some sort of assurance over your identity. Now, once you go into the RTA and you give them all this and they go through their process of validating all that info, they give you a token. Now, I realised actually after doing this that in the movie this was an invalid token, but it kind of proves another point. So we'll get to that. Now you get a token, and the idea here is that this is now a token that we can carry around with ourselves in order to authorise. Now this token also has a number of claims. We're not going to go into claims today, but all these things start to get related. So it's got a claim about obviously a picture and an address and a birth date and all that sort of thing. Now what happens is when you do go somewhere where you require access to content, rather than authenticating again, so rather than carrying your two Category A and your one Category B and all that other rubbish with you, you carry your token. And you present the token in order to have some sort of authorisation process. Now, inevitably, the authorisation process involves some sort of anti-forgery, which, again, in this case, didn't actually work, for those of you who know the movie. But there is a process there of validation. The theory is that once we're done, think of an authorization token, whether it be, say, an auth cookie in a browser or whether it be a token that you store on a device, as something that you can carry around with you everywhere. You don't want to carry your birth certificate around with you everywhere. You want to use that to prove identity, and then we're going to carry the token around. We're going to use that to authorize. So when we get into Web API, we've got a few different options here. So probably the easiest one, and the one that I think most of us probably use the most, is web app using Forms Auth. So very simple here. We have a web application. We're often using Forms Auth. When we use Forms Auth and we log on, usually through the membership provider, we get a nice little authentication cookie back. Every time we make a request, the authentication cookie goes back. So the authentication cookie becomes our driver's license. Somebody's already logged on once. That was birth certificate and all the category stuff. Now they're just providing that driver's license over and over again. Web apps using integrated auth, pretty typical sort of enterprise scenario there. So every time you make a request, your identity is passed with that request. Whether it's Web API or anything else in the ASP.NET stack, we can access user.identity and so on and so forth. Now the one for rich client is a little bit different. So when we go to a rich client, we need to have some other persistence mechanism. We're not necessarily going to send cookies with every request. We could, but it's not normally preferred. So now we get into tokens. And the idea again is that what we want to do is avoid sending creds with every request. And I think probably the one most important takeaway from this is don't create systems where you're actually storing the username and the password on the device. It's like walking around with your birth certificate and your passport and your citizenship and all that other rubbish from the RTA. You don't want to store that on the device because if someone gets hold of it, you've got a serious problem because that's data that goes way, way, way beyond the app. And unfortunately, passwords are like that as well. The passwords that you protect for people, I guarantee you the same passwords they've used on 50 other websites. So what you're wanting to do is store that token. Now, the idea is that we're going to authenticate them once, and depending on your app, that may be different. I mean, if it's a banking app, you want to authenticate before key processes. Most of your apps, though, something like your Facebook, I won't ask you to use Facebook, everybody uses Facebook. Something like Facebook, you've authenticated once. Every time you open up your phone, you've got everything there. That's a token being sent back with every request. Then there will be processes around invalidating tokens and recycling them and whatever else it may be. How you implement tokens in your API is going to differ case by case, particularly if you use things such as OAuth or other external providers. The thing I'm trying to get across here is that there are two different processes, and your authentication channel may be very different to your authorization channel. Once it all comes back into Web API, though, you want to tie it back into authorization filters. So you might say, okay, I'm going to store my token and I'm going to send it in a custom request or a custom header on every request. Now, every time I send that back, I'm going to decorate either my controller or my controller action or register globally an authorization filter which will say only admins are allowed to perform this particular action. And it works the same way in MVC, it works the same way in Web API. So the point there, try and use authorization filters, store tokens on devices, don't store credentials on devices. What we have to keep in mind with all of that is that you have to treat all of your APIs like they're public. So when we talk about auth, if we think back to the start of this presentation, the issue with the little phones on the table, and I said, look, there was one app there where the shopping centre had the control systems exposed. There was another one where you could pull everyone's username and passwords back. Other than the fact you probably shouldn't have any facility to do that ever, it's just missing access controls. And they can be discovered. So you've got to remember, when you put an API out there, particularly behind something that you're going to distribute to thousands and thousands of people through things like this, they will find your APIs. Expect every one of your APIs to be found, expect people to probe them and to see what they do. So I want to wrap up on a couple of points around devices. Did anyone see Colin's talk day before yesterday on Tesla, writing... All right, so he had for those of you who weren't there, he had a very, very cool talk on basically being able to instrument his car, and he was showing how he could see that his sister had left the car unlocked somewhere in Toronto, and I think people were quickly taking notes about where it was. But it was kind of cool because there are actually APIs on the car, and Tesla was standing up APIs which would then have a back end that goes through the car. And what we're finding is that we're getting all of these different things that do have APIs built into them. Now, some of these are very cool. Things like Nest, the one at the top left, is a thermostat for your home. And it is amazingly awesome because you can control it via your phone. It's not so much that that's the awesome bit, but because you can actually control the computer on it, you can say, look, I want to do things like change temperature based on certain conditions. I'm going to come home early today, so I'm going to turn the aircon on a little bit early. Belkin has connected PowerPoints. Philips have got these really neat globes. Damn expensive, but these globes, they all have, apparently all have little IP addresses. You can change colours and things from your smartphone. So these are pretty cool. But then you get to things like this guy. Did I miss something? Oh yeah, the fork. Put your hand up if you didn't want an internet-connected fork. Come on. This is not a joke. So the idea of the fork is that I think it was for weight loss, so that you, or rather dietary reasons, you could monitor how many. They had to be. So the gentleman at the front has decided it needs to zap you if you eat too much. I actually have some of those Withings internet-connected scales, so maybe you could combine the fork with the scales. And if you've been using the fork too much, the scales, I don't know. As APIs, you can do this stuff now. It's awesome. But it does have interesting security ramifications. So yeah, the one down the bottom left is called Lockitron, and that was actually a Kickstarter project a little while ago. And Lockitron can retrofit on your deadlock. So you see it's a pretty standard looking deadlock interface behind it. You can sit it over the top. And they say it's awesome because you can unlock your house with your smartphone. And I'm torn. It's like... But the really awesome bit is, get this, if you lose your phone, they can unlock it centrally for you. So, think about the opportunity. But I've been showing some of these at some of my talks, and one that I've showed a few times is the integrated toilet. Does anyone know what an integrated toilet is? I don't know. Well, we know it's from Japan because it's a toilet with lots of technology. But an integrated toilet, obviously, is one that you can control with your smartphone. So this is true. You can go. In fact, I saw this on the news just on the weekend, believe it or not, and I went, that's in my talk. That's awesome. Yeah. I think everyone heard that anyway. I don't need to repeat that. Anyway, so you can control the toilet with your phone. Now, it begs the question, what can you do with the toilet from your phone? So, you can do things like activate the sound module. It doesn't have it on here, but it's also got the bidet feature. Anyway, I was using this in my talks, and I was saying, we've got to be conscious that all of these things do have a security side to it. And as cool as it is, I don't even know if it's cool to have an internet-connected toilet, but as bizarre as it is to have a connected toilet, we've got to be careful because sooner or later there will be a vulnerability. Now, there's been a vulnerability reported in the toilet. This vulnerability. I don't even have to read that. You just can't make this stuff up. So I'll let you, let you all take photos and so on. But I guess what it does is just sort of brings home the fact that as cool as it is to build all these things and build all these APIs, we have all new security challenges, and I just can't even imagine how you'd exploit this one. But look, I think on that note, I might actually wrap up because I've just about hit time as well. So I would like to thank everyone for coming. I hope you enjoyed the bit, particularly the toilet unit. Do also fill out your evals. We'd really like to try and get feedback from people. There are other related bits and pieces. I do have a heap of these, and I've also got 5 minutes if anyone has any questions about this or security in general. Come on up. All right, who wants pluralsight? Do you want a month or a week? A stupid question. Here you go.